Hello and welcome back to another shell tutorial. Today I'm going to take you guys through how to make this material procedurally using Blender's material nodes. Alright, let's get started. So we're going to begin by clicking on the shading tab, and if you want to learn how to make this object, then you can check out my last video. Now we're going to select our object and click on New in the Materials tab. By default this produces a principled BSDF shader, and when we change the base color, our material also changes. Now to this, we're going to add a texture, but first we need to add our UV map input. And then we're going to go to Texture and select Wave Texture. Now I'm going to give you a brief explanation of what a wave texture is. Basically, you're producing a wave represented in 2D, with the white being the peak and black being the trough. This is represented as basically just a collection of black and white lines with a gradient in between them. And this can be helpful for creating the ringed patterns we see on the shell. As you can see, changing the distortion, the detail, and the roughness will change the amount of noise around the line, as well as the extent to which this is represented. Changing the phase offset will control where the peaks and troughs appear, which basically moves the lines up and down. Now we need to connect our UV input into the vector of our texture, and now we're going to go to Edit, Preferences, Add-ons, and make sure that you turn Node Wrangler on, and then save your preferences. This will make it so that when we press Shift Control and click on something, it will allow us to immediately view the texture without having to go through the whole node network. By dragging up this side panel, we can create a larger space, and I like to use this space for UV editing. So at the top, you can select UV Editor. Now I'll give you guys a short explanation on what exactly a UV map is. Basically, it'll turn all the faces of your model flat and treat them kind of like a net. And this is a really good way to map an image onto your 3D model, as you can see with this shell image to the left. Now, UV unwrapping is quite a difficult process, because you need to make sure that you select where your seams are, so the Blender knows where to cut the image, if you think of it like that. And anywhere there's a seam, there will always be a cut, but anywhere there isn't, Blender will always try and join the faces. As you can see, it's having trouble here because it thinks that you should stretch out the faces like this, because we haven't put an edge on the side. So now it can unfurl them. As you can see, this kind of method will produce more like an actual cylinder net, which is a lot easier for mapping the image onto our faces. UV mapping kind of just works like the viewport, but in 2D. So all the controls are the same, scaling with S, rotating with R. When we scale our faces past the border of the image, it starts to repeat, and this is one of the reasons why we're using procedural textures, as they effectively have no border. By pressing Tab A and selecting UV Unwrap, we can unwrap our object. As you can see, this is a far cry from the ring pattern we want, and this is because Blender's basically just making a mess of our object, and laying out the faces kind of randomly. And this is because, as you can imagine, trying to make the net of an object without any cuts is kind of impossible, so Blender has a hard time calculating what it's supposed to be doing without any seams. So you need to select the edges you want, and then go to UV, Mark Seam. From our smoothing last video, it left a bit of distorted geometry at the top of the shell, so I'm just going to quickly correct that. Make sure to be in Edge Select mode, as selecting 4 vertices will actually just select the face in between, whereas edges can go around that without selecting the face. Really good for making the seams you want. Now, when we UV unwrap this, we can see it's laid out much better. But there's still a lot of distortion, so we need to add more seams. As you can see, we're kinda getting closer to a ringed pattern, but in a later step, I'll show you why this doesn't really matter that much, and even the overlapping we're seeing in the UV map doesn't really matter that much, as this kind of method is very, very simple, and it doesn't require a lot of work. Basically, all we're really trying to achieve is minimizing the distortion and making sure that every face is presented on the kind of UV canvas. Now, if you're following along, I'm just going to briefly show you where I made my cuts. Now, it can help if, in the settings, you turn off the edge creases in purple and just have the UV seams in red. Now, I'm just going to select all of them for you, and this should save you guys some time, and allow you to avoid the trial and error like I had. Alright, and then I'm just going to select them all and isolate them, so you can kind of see where the cuts are going. Now I'm just kind of scrolling through our new UV map we've produced, and now I'm going to do the technique I told you about earlier that makes this really, really easy. And it mainly relies on Blender's processing. So we're just going to press SX0 and SY0 to scale these so that we've got a flat square structure. And once a single square is perfectly flat and aligned, we can just select it and make sure to set your selection to be square at the top. Then A to select everything and right click, follow active quads. And this will produce a massive shape with connected quad geometry, with the faces of a similar size. And basically, Blender's just laying out all our faces in this kind of similar pattern, all flat, following the edge, and this is giving us our striped pattern that we want, wrapping it around and getting smaller towards the top. Now we just have to repeat the process for the other UV islands. Now the next step is quite important. We need to scale the faces on the other UV islands so that the stripe pattern matches the stripe pattern of the other ones. And you might have to scale them quite a lot to achieve this. Then for our final island, we'll once again repeat the process and scale it up so that the pattern matches. Now this technique is good for procedural textures, but the net it produces is not very good for baking, so it wouldn't be recommended for video games. Now we're just going to save our file and call it UV unwrapped or something like that. Now the reason the lines get closer together as we move up the shell is because when we selected follow active quads for each UV island, we're representing the faces using a similar area. And this means they'll share the same proportion of our texture, regardless of their actual size on our model. So when we move from large faces at the bottom to smaller faces at the top, the texture gets scaled up, and the lines get closer together. To give a more organic look, you might want to add a tiny bit of distortion to these. And now I'm going to compare it to our reference image to see how high the scale needs to be for the number of lines we want. Now we're going to select Add, Converter, Color Ramp. As I mentioned before, our wave texture is a sine wave. So the peak is 1, pure white, and the trough is -1, pure black. Any value between these is represented as a shade of grey. The full bar of the color ramp represents your range, in this case from black to white. The position of the slider kind of functions like a greater than or lesser than, saying any values from this point to the maximum represent with just this color, and the distance between the sliders will still be a gradient. Using the eyedropper, we can select the colors on the color ramp from our image, so I'm choosing the orange and the off-white seen on our shell. Now our wave texture has custom colors, and you can adjust the color ramp to effectively change their thickness. Remember, the eyedropper tool is not the most accurate since it only selects a pixel's color, so you'll probably need to manually adjust these. Currently, we're just viewing colors. To see some shading, we need to connect the color output to the base color of our principal BSDF shader, and then Ctrl-Shift-click on the shader to instantly connect it to the material output. To add some surface features, we're going to go to Add, Vector, Bump. Then we connect the output to the normal of our BSDF shader and duplicate our wave texture. Then we can once again connect our UV input and Ctrl-Shift-click to view the texture. I want to represent this detail on the outside of the reference with thin and thick lines. And to do this, I'm going to show you guys a pretty cool approach where we can use two wave textures, and one of them is going to serve as a set of values to set the scale of the other one. This will produce bands where the scale is high and the scale is low, producing lines closer together and lines further apart, which I think will give an interesting look to the outside. To do this, we're once again going to use a color ramp. Let's use the scale from our previous texture, and then enter this as the value for our color. Unfortunately, any value above 1 is always going to be pure white, so it's really hard to see. By duplicating the color ramp, we can set one of the values to black so we can see it better. Then we need to connect the color ramp color output to the scale tab of our wave texture. As you can see, the effect isn't really working yet. And this is because you need to select RGB and select all the sliders and set them to the value you want. In this case, one of them is going to be set to 50 and the other 20, although I change these values later on. Now you can see we're producing one big thick line and many little thin lines in between. I want to be able to see the individual thin lines, so I set the value to be slightly lower. This will produce a band where the scale is slightly lower, so the lines will be further apart. Node Wrangler has some problems with this technique, as Ctrl-Shift clicking can sometimes erase it, so you need to bear this in mind, and you might have to reset your handles sometimes. Now we're going to connect the color output of our compound wave texture into the height of our bump node. The bump node will kind of produce a normal map type data, and this basically works by telling the shader to act like there's real geometry here, producing shadows underneath it. The height takes a black value and treats it as a low area, and takes a white value and treats it as a high area. You can control how far apart these are with the strength and the distance. This normal data is not being translated properly when we go into render view, and this is because in UV settings we need to uncheck instancer and choose our UV map. Now it's working like normal, and you can see there are shadows under these ridges, even though our actual geometry isn't that detailed. To view this better, I'm going to set up some simple soft lighting using some area lights. Using Shift-D, we can duplicate our light to the other side. I like to use soft lighting to see if my colors are vibrant enough. I don't really like how they look here, so I'm going to adjust them. I think the ridges look a bit too messy, and not as clean as they could be. Unfortunately, the distortion was set too high in the texture that controls the scale of our other one, so I would recommend setting it to low or 0. Now these colors are really clean, and unfortunately that's not very realistic. So I'm going to go to Add, Texture, Noise Texture. This is what a noise texture looks like on a flat plane. Like with our wave texture, we're mainly going to be adjusting the detail, roughness, and the scale. Unlike wave textures though, noise textures have a much wider gradient, and so they have a lot of different shades of grey. So it can sometimes be kind of hard to see the pattern that you're creating without a color ramp. I don't really like the effect that distortion has in noise textures, so I generally set it to very low or 0. Be careful not to set the linearity to be too low, as this will prevent us from seeing any of the detail of the noise texture. By default it's set to 2, so I think it's okay to just not touch this slider. Now we can view our noise texture and connect the UV input. I want this to sit around the spiral of the shell because it's going to represent dirt or sand that's stuck in there. And I'm going to choose quite a low scale to have big blotches. Now we're going to go to Add, Color, Mix Color, and connect our color output to the factor. Now we can connect our striped input to color A, and choose a dirty, dark, sandy color for color B. And adjust our color ramp until these colors mix in a natural kind of way. Turning this effect on and off, you can see the difference is quite subtle, but it will be more realistic in the end, so it's suitable for a photorealistic style material. Since seashells aren't entirely opaque, we need to expand the subsurface scattering section of our principal BSDF shader. The weight controls the overall magnitude of this effect, and the radii can be considered the red, green, and blue. Increasing all these values will produce a white subsurface scattering. And you can see here, lights going in and scattering out as white. It can help to view this effect if you use a high power backlight. Similar to some plastics, light is now able to go through the shell, and it has a kind of translucent effect. Now we can adjust the color of the scattered light by adjusting the radius settings. We want to go for this orangey look, similar to our reference image. Once you're happy with how it looks, you should probably save your file again. To keep everything organized, I'm going to move all my lights to a new collection, and this will make it easier for me to hide that backlight when I want to. To add some more detail to the shell's surface, I'm going to add another noise texture. This is going to represent damage to the surface, possibly by erosion, or maybe if it's just been broken away by it being dragged along the seabed. To start with, I'm going to connect the UV input to the texture. Although, I realized later that it doesn't really make sense for damage to follow the shell spiral, so you can skip this step if you like. We're once again going to use a color ramp to outline the black areas where we want to see the most pitting. To make these pits look more organic, I'm going to increase the detail and the roughness, so it looks like the damage has actually splintered the surface of the shell. We can view the effect this texture has by connecting it once again to the height of a bump node. To make it look like material has been taken away rather than added, we need to check invert on our bump node. And then we can use our color ramp like normal. To make the effect more noticeable, we can increase the strength of our bump node. Since the outputs of bump nodes are based on color, we need to add another mixed color node. As you can see, now the output is combining both of our bump nodes, and you can change the factor to control the influence each node has on the final result. I found that the detail is best represented when you choose a relatively lower strength for the lines and a higher strength for the pits. Adjusting your light sources can help you better see this detail as well. Viewing it up close, I find that I'm not really happy about how clean it looks in between where the pits appear, so I'm just going to adjust my color ramp to make it look more uniform. And here's our final result. Well done if you followed along this far, and please let me know in the comments what you'd like to see from future videos. Thank you very much for watching, and I'll see you guys again next time.